Alright, so for solving combined inequalities or compound inequalities, what we want to do is for the OR statements, we just solve each individually, then graph. Okay, with the AND statements, we split into two if it's not, and then solve each, and then graph. And the final graph is the overlap of the two. Alright, so we have these two things that need to be true at the same time. So let's start with this one. Minus 2 gets C is less than or equal to 1. And then here we have to add 4, or no, minus 4 rather. Minus 4. Negative C is greater than negative 2. So multiply both sides by a negative 1. And then we get C is less than positive 2. So C is less than positive 2 would be this. And solve them both first before you graph, because you never know which one's going to end up being bigger sometimes. And then C less than or equal to 1 would be here. Going this way. Since it's an AND statement, it has to be where they both overlap. So it's going to be here. That's where they overlap. That's your final answer. Alright, so let's solve another one here. Negative n is less than 2, so we multiply both by a negative 1. And that gives us n is greater than negative 2. And then or, add 3. 2n is greater than 8, so n is greater than 4. So n is greater than 4 would be this. N is greater than negative 2 would be this one. Since it doesn't matter, they don't have to overlap, it's where one or the other or both are true. Well, one or the other or both are true from here on. So that's your final graph. So let's do a few more examples here. Here's an OR statement, so we just solve each individually. Add 1 to both sides. And I have 2x is less than nothing. Oh my gosh, what happened? Oh, it's negative 1 plus 1. That's just 0, right? Divide by 2, and that's still x is less than 0. The second one would be add 1, and we get 2x is greater than 2. So x is greater than 1. So x less than 0 would be that way. And x greater than 1 is this way. So your final graph is this and that. Alright, because it's either this one or that one has to be true. So here's another AND one. This is what I was talking about, splitting it into 2. So 4 is less than 2x minus 2, and 2x minus 2 is less than 10. Alright, this is going to be the best way to get the correct answer every time. So add 2. We get 6 is less than 2x, divide by 2, and we get 3 is less than x. And then we have to add 2, and we get 2x is less than 12, so x is less than 6. So x is less than 6 would go this way. Oops, 6. It's going to be that way. X greater than 3, that's the same as x greater than 3, right? So you can do the little arrow thing and know that our arrowhead's going to point this way. It's only when the variable's on the left. So where x is greater than 3 is this way. So our final answer is from 3 to 6, because it's where they have to both be true. Alright, and 3 more examples and then you try. So we split this up and we get 14 less than or equal to 3h plus 2. 3h plus 2 is less than 2. So subtract 2 from both sides, and we get 12 is less than or equal to 3h. Divide both sides by 3, we get 4 is less than or equal to h. And then here, minus 2, we get 3h is less than 0. Here we divide by 3, and we get h is less than 0. So h less than 0 would be this. H less than or equal to 4 would be this. Since they have to both be true, what we're going to do is graph from here on. That's where they have to both be true.